Ever wondered how the universe categorizes its myriad of stars? Picture the cosmos, a vast expanse filled with twinkling bodies of light. Each star, a unique entity, burning brightly in the darkness. But did you know that these celestial bodies are as diverse as they are numerous? That's where stellar classification comes in, a system that helps us understand the kaleidoscope of stars scattered across the universe. So, buckle up and prepare to dive into the world of stars and their classifications. Stellar classification, ever heard of it? Well, it's a fascinating system that astronomers use to categorize the billions of stars in our universe. It's much like how biologists categorize animals, only in this case, stars are the subjects. Now let's dive into the depths of the cosmos and discover how this works. Think of the Hertzsprung-Russell, or HR diagram, as a star's ID card. It plots a star's luminosity, its brightness, against its surface temperature. A stroll across this diagram is like a tour of the universe. In the upper right corner we find the massive hot stars glowing intensely. Down in the bottom left we encounter red dwarfs, the faint cool stars, often overlooked but incredibly common. But how do we tell these stars apart? Enter spectral classification. Stars, like people, have unique traits, and in this case it's their spectra, or the light they emit. By examining a star's spectra, we can identify its chemical composition and temperature, and based on this, stars are assigned letters. It's like giving them names, only these are alphabet soup of O, B, A, F, G, K, and M. But wait, there's more. Stars also have what we call a luminosity class, denoted by Roman numerals. This reflects a star's size and its stage in its life cycle. It's like knowing if a star is a toddler, a teenager, or a grand old entity. So you see, stellar classification is more than just an exercise in labeling. It's about understanding the life and personality of a star. It's about knowing if a star is a hot-headed young entity, a stable, middle-aged star like our sun, or an old, wise, and possibly dying star. It's about understanding the universe one star at a time. Stellar classification is not just about labeling. It's about understanding the life and personality of a star. Ever wondered where our sun fits into the cosmic picture? Well, let's dive into the world of the main sequence stars. These stars, including our sun, are the most common stars in the universe. They're the steady workhorses of the cosmos, quietly fusing hydrogen into helium in their cores, and they hold a significant place on the Hertzsprung-Russell diagram. The HR diagram you see is a stellar roadmap, plotting a star's luminosity against its surface temperature. If you were to look at this diagram, you'd find main sequence stars tracing a distinct diagonal path from the upper left to the lower right. This main sequence is more than just a pattern. It's a celestial biography, illustrating a star's journey from its youthful, hot and bright phase to its mature, cooler and dimmer stage. Now, characteristics of main sequence stars vary greatly, with their mass being the defining factor. Massive stars, for instance, are hot, bright and blue, dominating the upper region of the main sequence. They live fast and burn out quickly, often in a few million years. On the other hand, smaller stars, like our sun, are cooler, less luminous, and yellow or red in color. They sit comfortably in the middle or lower regions of the main sequence, living a long and steady life that can span billions of years. Underneath their calm exterior, main sequence stars are powerhouses of nuclear fusion. The core is where the magic happens. Hydrogen atoms collide and combine to form helium, releasing a tremendous amount of energy in the process. This energy makes its way to the surface, radiating out into the universe as light and heat. It's this energy that makes life possible here on Earth. Main sequence stars are the universe's consistent performers. They might not have the drama of a supernova or the mystery of a black hole, but they're the steady, dependable players in the cosmic orchestra, quietly creating the elements that make up the world around us. So the next time you look up at the night sky, take a moment to appreciate these unsung heroes of the cosmos. Main sequence stars, they're the universe's consistent performers. What happens when a star gets old? It's a fascinating question, isn't it? Stars, much like us, change as they age, going through various stages and transformations. The life cycle of a star begins with its birth in a dense cloud of gas and dust, known as a nebula. Over millions of years, the star grows, becoming hotter and brighter as it fuses hydrogen into helium in its core. This stage of a star's life is known as the main sequence, where it spends the majority of its existence. As a star exhausts its hydrogen fuel, it begins to evolve. It swells into a red giant, becoming much larger and cooler. The star's outer layers expand, and its color shifts from white to a deep, fiery red. This stage is marked by tumultuous nuclear reactions that cause the star to pulse, changing in brightness over time. But even the grandeur of a red giant is not the end. As the star sheds its outer layers, it reveals a hot, dense core, now known as a white dwarf. These tiny stars, no larger than Earth, glow with a pale white light, slowly cooling and fading over billions of years. For the most massive stars, their fate is even more dramatic. These giants collapse under their own gravity, forming a neutron star, or in the most extreme cases, a black hole. Neutron stars, the smallest and densest stars in the universe, spin rapidly and emit intense radiation. Black holes, on the other hand, are regions of space where gravity is so strong that nothing, not even light, can escape. So you see, stars, like living beings, have their own life cycles. From their birth in a nebula to their final stages as white dwarfs, neutron stars, or black holes, stars undergo incredible transformations. Each stage of a star's life is a testament to the beauty and complexity of our universe. Remember, though, while we've learned a lot about these celestial bodies, there's still so much more to discover. Stars, like living beings, have their own life cycles. Ever heard of a star that could outlive our own sun? Such stars exist, and they're called red dwarfs. These celestial underdogs are the smallest and most common stars in the universe. Despite their modest size, they are fascinating in their longevity and potential for life. Red dwarfs are so called because of their red hue, a result of their relatively low surface temperatures. They are frugal burners, slowly consuming their hydrogen fuel over an extended period of time. While our sun, a yellow dwarf, has a lifespan of about 10 billion years, a red dwarf can keep burning for trillions of years. That's right, trillions. Such a long lifespan means that red dwarfs could potentially outlive most other stars in the universe. But that's not all. Their longevity, combined with their stable burning, makes them promising candidates for hosting potentially habitable planets. These planets could have a stable, warm environment for billions of years, giving life a chance to evolve. So don't let their size fool you. These tiny stars could be the cradles of life in the universe. But the universe is not only about red dwarfs. There are other unusual stars out there, each with their own intriguing characteristics. Take Wolf-Rayet stars, for instance. These massive, bright stars are rare and short-lived, but they put on a spectacular show. They shed their outer layers in powerful winds, creating beautiful nebulae that are a treat for astronomers. Then we have hypernovae, stellar explosions that dwarf regular supernovae. They are among the most energetic events in the universe, outshining entire galaxies for brief moments. And let's not forget variable stars whose brightness changes over time. Some of these changes are regular, like a cosmic heartbeat, while others are unpredictable and chaotic. The cosmos is full of wonders, and stars are no exception. So, why should we care about stellar classification? Well, stellar classification is akin to the biological taxonomy of the universe. Just as biologists classify living organisms to understand their evolution, astronomers classify stars to comprehend their life cycles. Understanding the classification of stars, from the luminous blue giants to the faint red dwarfs, allows astronomers to predict the future of these celestial bodies. Will they end their life cycle in a serene fade, or will they explode in a dramatic supernova? These are the questions that stellar classification helps answer. But stellar classification isn't just about individual stars. It's a tool that aids astronomers in studying the evolution of entire galaxies. By observing the types of stars within a galaxy, astronomers can infer its age and past as well as predict its future. A galaxy full of blue giants, for instance, is relatively young and full of stellar activity. On the other hand, a galaxy dominated by red dwarfs is likely older and quieter. And let's not forget the search for extraterrestrial life. Stellar classification plays a crucial role here too. By identifying stars similar to our sun, Astronomers can focus their search for habitable planets and potentially extraterrestrial life. This is because stars, like our Sun, have proven to be capable of supporting life, well, at least on one planet that we know of. So you see, stellar classification isn't just a bunch of letters and numbers. It's a universal language that deciphers the secrets of the cosmos. It's a conversation with the stars, a dialogue that unearths the mysteries of the universe. Stellar classification, it's the key to understanding the universe's celestial bodies.